This idea that technology, and particularly smart technology that is replacing us, is going to replace us, steal our jobs, lure away our children from our influence and so on, is not new. There's this beautiful book from 1956 called Automation, Friend or Foe, which I highly recommend that you read, if nothing else, for the very interesting information about how far we have in fact become. And this book precisely deals with the topics that we deal with today in AI ethics. It's like, what is the impact that machines are going to have on us? And towards the end of the book, they talk about this new thing called computers and how they will have impact on us. And just a tidbit from the book, the first aircraft air pilot was developed by the Sperry Corporation in 1912. I found that very super interesting. So AI has existed since 1956, actually, and it is not the first, it is not its first rodeo of being in the highlight. But until now, we were not really talking about AI impact on society, AI ethics, or machine ethics, or anything like that. So I wanted to just spend a little bit of time to say why not. So the reason why not is that systems with ethical impact were designed by professionals to be used by professionals. So for example, if you take that same air pilot, which is much more sophisticated today than the 1912 version. It uses a lot of smart systems and smart control and so on, but it was built by professional developers and engineers, and it is to be used by specifically trained people to use it. Now, this is very clearly visible in things like air pilots, but is not so clearly visible when you have software. And something happens when you cannot when you are not building for professional users, but when you're building for the general public. You cannot predict how they will actually use it. So an example, we have these things that are smart speakers, home assistants, whatever you want to call them. They live all over the place, and they're here to make our lives easier. And while they make our life easier, they make the life of the people who need to develop them harder. So an example of things that can happen to which we need to have a solution, but we don't necessarily have one. So let's say you ask your search smart speaker, who wrote 1984, there is you know what the correct answer is, that is not what you need to program the system to do, to just reply George Orwell, fair enough. But if then people ask all kinds of funny questions, particularly children ask funny questions, but all people ask funny questions. So it could be the question of, how do I kill myself? Now, how do we answer here? I mean, there is the factual answer, which is there are all of these methods ranked by type of method, how lethal they are, and time it takes to execute from execution to death. Now, is this the thing that serves society most, to have a factual answer? Maybe not. Then we need to think about, what did this person meant when they asked this question? Were they Agatha Christie wannabe writing a novel and they just need factual information? Or are they a person who is in a crisis and actually needs to be helped rather than given factual information? So this situation is basically what is a situation that happens with computation today. Computer programs used to be rooms that you enter in, and we knew exactly who is allowed to enter the room. Then there used to be a furniture in the room. This is the example of the furniture. It's a Polish computer from 1960s. And we knew exactly where it was. It wasn't connected to anything except power. Then they became then they became like objects in the room, but you could still kind of track the cables and see who they communicate with, and you can see that there is a computer there, even though you don't, you will maybe misappropriate the computerness to the monitor, not to where the CPU actually is, but you know there is a computer there. Today, computer programs interact with other computer core programs without human oversight. We have a kind of a situation of ambient computing. You do not necessarily know that you're interacting with the computer or where the computer is. There is a computer in your washing machine. Programs can be and your washing machine may soon be connected to the smart grid and talk to other washing machines on the smart grid, and you have no idea. Programs can be acquired and used by people without professional training, and this is the interesting part. And so all this spells that there is no working envelope. We do not know what the sphere of impact of the computation is. It's completely open. And because it is completely open, then it's going to have an ethical impact on the world, on society, and on individuals. So this field of AI ethics in general was built to study how to ensure that no negative ethical footprint of AI in society is generated. So how do we avoid negative ethical footprints in society? There are two methods, I would say, that kind of take different approaches to this, and this is not to say that they're completely split, and it is completely ungrateful to have taxonomies in AI ethics, but I'll try and I'll sin. So the first method is about ensuring that there is the possibility of adequate human oversight of the activities, research, development, deployment, interaction with AI in society. So how do we ensure that adequate continuous human oversight is awarded, right? And in this group, we talk about things like responsible AI, accountability, transparency, explainability, fairness, privacy, and trust sometimes, reliability, and so on. Now, I don't want to spend time explaining what all of these things are for two reasons. One, I will show you a resource in which, of a YouTube video in which I do that, but we have an entire course planned for PhD students, shameless plug, in the next semester, together with the University of Oslo class. We will talk to you about it. We started talking, but you haven't received an update, sorry about that. Yeah, so you can either register from the UAB side or the Oslo side, and which is all about these topics. Now, the other topic, the other approach is how do we make sure that the machines themselves behave ethically? So how, instead of having a human oversight to ensure that no negative footprint is left, ethical footprint, how about we actually make the machines in such a way that they themselves behave ethically and don't require human oversight to be maintained the whole time? And this is the field of machine ethics. So basically, machine ethics is concerned with the behavior of machines towards human users and other machines. Rather, how do we make machines behave in a particular way towards human users and other machines? A particular being an ethical way. Of course, this definition is just from this paper, which is a 2005 AAAI symposium in which a lot of definitions of machine ethics come from. And if you want to start reading about this field, this is where you start. So let's talk a little bit about what machine ethics is. There are two interpretations of machine ethics. On one side, you can pull it towards the humanities side. And in this, we are talking about what does it mean? What does ethical behavior for machines even mean, right? What does it mean for a machine to be a moral agent? What type of ethics should we use for machines? And all these nice, yummy questions like that. So I thought that I should illustrate the situation here because I expect a lot more people in this crowd from technology disciplines rather than for humanities. Just so that, because people speak all the time that, oh yeah, AI people, they have to be educated in ethics. We have to educate companies in ethics. You cannot just do this AI. Our students, they need to learn ethics and so on. So I just wanted to very briefly with this example or explain what the situation is. So the situation of asking from humanities to educate computer scientists and AI specialists in ethics is a little bit like coming up to a person that is in biology and saying, please explain to me how manticores reproduce. And this guy will say like, you're crazy, but I don't want to be impolite, so I'm going to tell you, well, you need a zoologist, I'm a botanist. So then you kind of go ahead and find the zoologist and then say, please explain to me how manticores reproduce. And the zoologist goes, well, you're crazy. Manticores are invented beings. We have no idea. We study real things. And pretty much it's the same situation. Like humanities have not yet studied what does the term ethical behavior mean for machines. But if you pull that definition of machine ethics, being concerned with the behavior of machines towards human users and other users, then we have a much more practical question. And that practical question is how to automate moral reasoning. So before we go into how to automate moral reasoning, the question is why to automate moral reasoning, of course. And this thoughts about moral reasoning and work about moral reasoning is centered typically about around decision making. And this is decision making that is done by machines. And I think you picked up by now that when I say a machine, I mean both software and embedded software and software that has a body like a robot or a car or something like that. So decision-making, reminder, is a process that consists of at least 4 steps. The first one is to identify the problem for which a decision needs to be made. The second is to evaluate the objectives and preferences that apply. The third is to analyze the decision problem and its constraints and develop or identify the possible options from which to choose. And the fourth is to choose from the identified options following some reasoning. Now, machines are typically involved in this third step and in the fourth step. And it is in these thirds and the fourth steps that we are trying to kind of say, well, when you're doing reasoning and you're taking into consideration the problem's constraints, identifying possible options, how to choose from the possible options to satisfy a particular objective, then you should also take into consideration morality of the particular options in the situation. So what is the difference between regular decisions and moral decisions? A moral decision is a choice made based not only on the factual objectives, preferences, and constraints, but also based on a person's or society's, nice spelling, Maria, society's consideration of what is moral behavior. So that means basically, if I go to site Hare, which is a source of these thoughts, typically, moral decisions also include considering the interests of others as of equal weight with one's own. So let me simplify, what does that actually mean to us that build algorithms? So basically what we are looking for is a box. I just started pointing with the pointer as if I'm in front of a real screen. Lovely. Okay, let me find my pointer here. Yep, there we are. So we want to build this box, right? And we assume, yeah, I'm pointing in the box. We assume that we are given some definition, some description of the problem for which we are wanting to make a decision. So this is typically some description of the context or some options. We actually have information about the abilities of this, of the reasoning abilities of the system for which we want to build the moral reasoning algorithm. And we assume that we are given some information, some moral information about what is right and what is wrong. And what we want to take to build some kind of an algorithm that takes both of these things into account and then outputs moral choice. So it basically does decision making, but while being sensitive to the morality of particular options or particular situations. Now, what you're typically thinking about here, about what are moral choices, is a moral dilemma of the trolley problem kind. I took this picture from the Moral Machines project. I didn't put a link because I think it's very well known, but if somebody needs it, I'll give it in the chat. And people think moral decisions being something like, should the driverless car whose brake have failed run over passengers or run over an embankment and kill the passengers either it should kill the pedestrians on the street or it should kill the passengers in the car. This is, people get very excited about this type of problems, but in fact, they don't matter, right? Murder is easy, to quote Agatha Christie. What is a little bit more deep, because apart from it being immoral, is also illegal. And these type of situations are not the hard situations to solve. The hard situations are the ones that don't involve murder and mayhem. So a thing that you don't think about as moral choice, but it is actually a moral choice, is something like this. So social media platforms, for example, deciding whether or not particular posts should be labeled as mendacious, as lies, as fake news, as possibly distorting the truth, and in a way that is negative for society, right? So these are moral choices that machines actually need to make, that are they're very hard. Now, as people who work not in humanities, so everything else, not in humanities on this problem of machine ethics, we typically are just assuming that somebody is going to supply to us some information about moral values or moral obligations that the machine needs to build into the algorithm that does moral reasoning. As programmers, as engineers, we really do not want to be the ones to make the choices of what matters or what is right or what is wrong for a machine to do. And so pretty much all the projects that I know, people are just like, yeah, we assume we are given this type of information, then this algorithm will work for this type of information. And we really, really don't want to be the ones to choose what it means for a machine to be moral. However, that being said, it turns out more and more that we are actually put in a position to build one more box here, and that is a box that takes input on moral information, for lack of a better, more precise term, from different sources, and then resolves possible conflicts among it. And so this box, this little box, is something that I'm actually specifically working on at the moment from very many different angles, because I find it particularly interesting given my background in collective reasoning. Now, this box is also typically where moral philosophers and other types of philosophers, some other types of humanists like to very much argue with me, and I like that argument. So just to clear up a little bit of why do we actually need a box that does conflict resolution of any kind, right? So why do we need moral conflict resolution? So to program a machine to do the right thing, we need to know what the right thing to do is, right? And now, so of course, justifiably so, there are many moral theories who argue that moral conflicts don't actually exist. What we are arguing is something completely different, that the right thing is the right thing. There is no doubt about it, but sometimes we do not. There are other issues that need to be resolved that are not moral things. And to this, I will take a snippet from a paper by Jeff Horty called Moral Dilemmas and Non-Monotonic Logic, which is an old paper now from 1984, in which he says, why do we need to resolve moral conflicts? For one thing, the task of actually applying a correct moral theory to each of the ethical decisions we faced every day would be difficult and time-consuming, and it seems unlikely for most of us that such a theory could have any more bearing upon our day-to-day ethical reasoning than physics has upon everyday reasoning about objects in the world. Most of the common sense ethical thinking seems to be guided instead not by dictate of moral theory, but by simple rules of thumb. Return what you borrow, don't cause harm. It is not hard to generate conflicts among these. So there is a footnote there. Who he is citing here is a talk by Daniel Dennett, the moral first aid manual that he gave as Tanner lectures on human values in 1986 at the University of Michigan. Basically, the idea here is, regardless of how you feel about moral theories, people use in practice rules of thumbs, and among them there are conflicts and we need to resolve them. So even if you want to take the high road, moral conflicts don't exist. Conflicts between rules of thumbs do exist. The other thing is what I called here tech colonialism versus ethical relativism. Different societies have different views about what is moral and what is not moral. And this example I like very much. It's a comic that because it also illustrates the problem that moral philosophers have with conflicts. So here, moral philosophers, we say, we agree that the problem is we have a male-dominated culture. We just don't agree as to what constitutes, what are the symptoms, what are the effects of that male-dominated culture. We agree that murder is bad. We don't agree whether abortion is a murder or not. So the problem is not on the what is good and bad, but the problem is what counts as what. As computer scientists, I would say that doesn't matter too much to us so much, because everything becomes a list at the end, and we have conflicts that we need to resolve anyway. But I think back to the tech colonialism versus ethical relativism, you would need to be able to kind of, if nothing else, make sure that when you build a machine that is capable of ethical reasoning, it takes into account adjust for differences between societies in which it is deployed. And to expand a little bit further on that point, when we are talking about morally sensitive situations and decisions, there are actually 3 different types of sources of what counts as right or wrong. The one source is the law. Some things are unethical and they're also illegal at the same time. Then we have rules of society, and then we have personal views of what is right and what is wrong. To some people, putting pictures of their children on the web is completely immoral. To other people, this does not matter. So do we want a phone that does not allow you to upload pictures of your children on a social network, right? Because if we implement rules, one moral rule for everybody, this is what it means. It means that you don't have a personal choice. that a society doesn't have a choice, that different legal systems don't matter. This is not what we want. We want to take into account all of these different sources on particularly different topics and see how they interact, and they may be in conflict, and we need to kind of see what overrides what where. So that's enough overkill on the why we need that extra box. I'm personally attached to the extra box, hence there's so much time on it. The point that you have all been waiting for, how do we actually do it? How do we actually build moral reasoning algorithms? That is not, again, the question. The question is, what can we do, right? So this is where everybody gets confused, and we have people from different disciplines talking about machine ethics. There are sparks. Why? Terms that we use in AI come from humanities. Trust, agent, moral agent, intention, autonomy, will, control, choice. These are all terms that are from humanities, and they have a meaning there. What we have done when we have taken them into AI, we have overloaded them, to use a C++ term. We overloaded their meaning, right? They mean something completely different to us, but we don't always spell this out. So, for us in AI, an agent is not the same thing as an agent in philosophy. So to us, an agent is an entity that acts in an environment. It has abilities, goals, prior knowledge, and it is able to perceive stimuli from the environment, and then plan its actions, and it's according to its goals and preferences, execute these actions in the environment, and then see what the effect they have, and so on. This is the definition from the citation down there. So these different agents then, in philosophy, an agent is an atomic term. Autonomy is an atomic term. Whereas in AI, this is more like a long int scale. So there is a range of abilities of an agent, how much agenting it can do, to be more precise, how much autonomy it has. So we have different levels of autonomy. So this is a scale that is the most core scale of how autonomous an agent can be. We distinguish between, in AI, as in autonomous systems, the difference between different levels of autonomy is basically defined by how much human control does the system need in order to operate. So how much this AI agent, how much input it needs from a human in order to do its thing. So we distinguish between control systems where humans have full or partial control, such as an ordinary car or an iron, no automation whatsoever, no agency. We have supervised systems which do what an operator has instructed, such as a program lathe or other industrial machine. Lathe is basically this thing in which you put a chunk of wood and a nice little carved spoon comes out. So an example of this is a toaster. It's capable of some unsupervised action. You press the button, it roasts unsupervised, and it stops. Then you have to retrieve the bread yourself. Then we have automatic systems that carry out fixed functions without the intervention of an operator, such as an elevator. So you just walk in, it's there, it exists, you use it, you leave it, you don't worry about it. An example of this is the next generation washing machines that are plugged to the grid, to which they have a tank for washing powder. You put in the stuff, and it switches on when the power grid has a lot of energy in it. And then on the last case of this, we have autonomous systems that are adaptive, learn, and can make decisions. And this is where the rabbit hole begins, because this in itself is kind of like a long end situation. Some of the most autonomous systems we have today are these robots that we have rovering around Mars. Now, I know what you're thinking, Trondheim. I got you. So the same scale has been adapted for cars, but what is more interesting perhaps to you, to ships. So you have exactly the same levels of autonomy in ships as well, basically depending on how much input from humans they need. So this particular slide comes from the source in the bottom, but there is a nice paper from the Sintef in Trondheim, from I will pronounce the name, Ornulf Rodseth, defining ship autonomy, but characteristic factors. If somebody wants to dive into it, it's very awesome. Now, given that agents, computational agents have different levels of autonomy, we can only pose different levels of ethical behavior and expect different levels of ethical behavior from them. So this idea was originally introduced by Wallach and Allen. in which they kind of look at how capable of moral reasoning different systems are based on how much autonomy they have. And then they distinguish between systems that have operational morality, where the moral significance of the actions of the system lies entirely in the humans involved in their design and use. So the machine does something, but the moral decisions can be traced back to choices that people have made. And then you have functional morality, which refers to the ability of the artificial moral agent, the computational agent, to make moral judgments when deciding a course of action without direct instructions from humans. So we have programmed it somehow to discern right from wrong. And then you have full moral agency that nobody bothers to define, but it means like as some people, right? So this is chapter 2 of this book, which is very interesting read. The idea of types of moral agents is perhaps a little bit more refined in this paper by Moore, the nature, importance, and difficulty of machine ethics. Now, if you don't want to do research in machine ethics, but are just a bit curious about the definitions, then this is a very nice paper to read, light, 4 pages, awesome. And Moore distinguishes between 4 types of moral agents, which overlap with the Wallerheim agents. So he distinguishes between ethical impact agents, implicit ethical agents, explicit ethical agents, and full ethical agents. So ethical impact agents are basically agents that don't necessarily make ethical choices themselves or are involved in ethical decision-making, but by simply existing, they change the morality of the world for better or for worse. So this is like introducing a camera and a microphone in the coffee machine. They don't make ethical choices at all, but they're there. So all of a sudden, the autonomy of the people is restricted because you know that what you say is going to be recorded, so you're going to be careful what you're saying. Moore gives a better example with robot camel jockeys in Sudan. Implicit ethical agents are agents that are involved in morally sensitive situations, but they do not themselves discern between right and wrong. Basically, you just kind of constrain certain actions of the agent. You as a programmer know that you're doing it because those actions are morally wrong. But you don't pass on this information to the program. You just basically say, well, if context X and decision choice Y, then do Z, and that's it. Explicit ethical agents are agents that are capable to use their autonomy, whatever level of it they have, to make a discernment, to make a distinction between morally right and wrong. So you have passed on information about what is morally right or wrong. You don't only constrain agents. And again, full ethical agents, human level. So how do we actually go about building implicit and explicit agents? So Wallach and Allen, same people, they say that, well, there are basically 2 approaches. This is common sense. There is the top-down approach and there is the bottom-up approach. And there is hybrids that nobody has seen yet, but we are hoping. What is the top-down approach? This comes from engineering. In engineering, a problem is iteratively divided into smaller problems until a problem small enough to be solved is reached. Right? So I need to find the shortest path. So can I find, you know how it works. So in machine ethics, this means doing a top-down approach means that you are given some ethical theory, which is basically a system of reasoning about what is right and what is wrong. And then you're asking about how can we implement it. Now, if you're building explicit agents, then this question is how can we build the agent to follow a given moral theory? And if this is implicit agent, then you're asking how can we follow a moral theory to build an agent that does moral decisions. So a lot of the work that has been done in machine ethics actually follows this top-down approach, and people are looking at particular almost at random chosen ethical theories or part of ethical theories and trying to build explicit agents or more explicit agents with them. So there are some limitations of top-down approach to explicit agents or agents in general, and I think you can already guess as to what they are. A lot of moral theories pose idealistic standards that are hard to be met even by people. So it's completely not clear how they should be implemented by machines. But the more important thing is that this approach requires hard AI problems to be solved, such as situational awareness or prediction of consequences, particularly if you're using some consequentialist-based theory. There is a lot of context dependency due to the high AI requirements. So you can say, well, okay, I am not going to solve these hard AI problems of situational awareness and prediction, but that means that I have to make some assumptions about what the context of operation is. So then you build a system that works in a very limited context. And of course, there is the problem which theory should be used, which we are completely skirting because we're saying somebody will tell us. Nobody will tell us, but you know, one can dream. There are advantages. There are no surprises if you're using a tried and tested theory. So you know exactly what to expect, what is right and what is wrong. And then you can just test whether what you have expected the system to do, it actually does. And the biggest boon, I would say, is that the behavior can be verified. We can check if the action of the agent complies with the theory recommended for the given situation. And in fact, I have worked, still occasionally work in the problem of formal verification for ethical behavior. So we can actually do that when what we are doing is a top-down approach. In contrast, we have the bottom-up approach. So in engineering, this means we don't describe how to solve the problem, but you describe the solution itself. So then the system learns to reach this solution, typically by being rewarded or punished for wrong choices or given other types of guidance. So in machine ethics, this means that we want to actually train an agent to behave morally. So then for explicit agents, this means how to build an agent that discerns right from wrong by being given examples of right and wrong, or some description of what is right and what is wrong. For implicit agents, this means how to build an agent that learns a behavior which in specific contexts is moral. So just to explain on this last point, what is the difference between explicit and implicit here? So what is the difference in training? I will give you an example of in AI. I will discuss very briefly how we solve problems in AI. There are basically two problem-solving methods. The first one is to simplify the environment because we don't have true intelligence, right? Yeah, okay. The first approach is to simplify the environment. The second approach is to simplify the agent. So what do I mean by that? You can, this is the working envelope. You can guard off a particular part of the environment in which you can know exactly what's going to happen, what is expected to happen, and so on. And then your system can do some complicated actions and get the job done. So an example of this approach is your Roomba robot or any kind of vacuum cleaner of this family. They do not operate in just about any environment. You can only have them in a particular room floor, so either carpet or cork or tiles and so on. And you have to guard off the areas in which they should not go, such as stairs. So when you buy this machine, you get these, what are they called? These little towers that form an invisible wall that the machine cannot cross. So we are simplifying the environment. And then in this environment, they can do complicated actions like, find their own charging station, clean, or even the more complicated versions with, detergent and water and soap and clean and so on. And when something unexpected happened in the environment, the machine cannot handle it. And the unexpected thing in the environment typically is if you have a pet and there is some pet manure, then there is a horror story, right? The system cannot handle surprises in the environment. The other approach is to simplify the agent as well. So so you leave it in the environment unpredicted and completely messy as it is, but then the agent cannot do much. It does particularly one action, and then if it is in the right environment, this one action actually leads to the accomplishment of the goal you want to accomplish. And the example here is this thing that they used to sell at Technic Magazine, which is basically a ball of fuzz that vibrates. So if those ball of fuzz is somewhere under the bed with the dust bunnies, it's going to collect all the dust and you actually are going to get a Stoffsugar. But if it is somewhere on tiles or somewhere in the grass, it's not going to do anything. But you can still put it in the tiles and in the grass. It's not going to do anything, but it's not going to be harmful either. So this is this last approach of building implicit agents bottom up is basically figuring out this simple decision strategy that they can learn that in a particular context is basically like this fuzzball that collects the dust bunnies. So the idea behind the moral bottom-up approach is not surprising. People make moral decisions without following a specific moral theory. It saves us, in fact, from negotiating about what is the right thing, what is the right moral theory to follow. And the strength of bottom-up engineering in general lies in the assembly of components to achieve a goal. It's more flexible, dynamic. It doesn't require you to predict the context. The idea is that instead of learning how to always be moral, an artificial agent will learn that little by little, and this is what people do, so it's kind of more intuitive, natural. But there is no clear approach as to how to do this. So there are two, I would say, families of approaches. So the first one is, one of the first examples in it is by Anderson and Anderson, where they build they call a general ethic dilemma analyzer system, in which they have a bunch of examples of cases in medicine about right and wrong, and they build a system that learns from these examples, and they use a symbolic learning method here. They use inductive logic programming, in fact. And there are a lot of systems that take a symbolic learning method. And then there is the reinforcement learning approach. This is one of the examples, one of the early examples of that, in which what you're trying to then, you're given a particular objective function that your machine needs to satisfy. So there are limitations to this approach. Clearly, there are no safeguards how to be sure that a reasonable behavior will be learned. In fact, we have examples in which this does not happen. So the notorious example here is the Thai chatbot by Microsoft, I believe, which was unleashed on Twitter and was supposed to learn how to interact with people like people. But then very shortly, it was being deliberately taught by some people with funny sense of humor to behave, to pour out sexist and xenophobic and anti-Semitic statements, and it was quickly taken down. Again, this approach requires hard AI problems to be solved, such as situational awareness, prediction of consequences, learning from the environment. The actual hard problem here is how to specify, find the right examples, or the right amount of examples, or the right objective function. And a lot of you will notice that there is no supervised learning used here. There are no neural networks, nothing like that. And the reason for that is because the training data is very much not free and not existent. Like examples, convenient examples for you of right and wrong in the context in which you want to build a system, not available. If you want to do this kind of a business, you have to build your own training data, and you can't necessarily ask mamas and Turkers to do it for you either. But there is also the very hard issue of how to verify or prove that ethical behavior really has been reached here. So we do not have the same verification options that we have with top-down. The advantages are robust, supportive of autonomous behavior. So this approach, like it's much more powerful if you can get it. And we do not have to worry that we have forgotten to specify some rule. So I didn't mention it in the top-down approach. Basically, the system does exactly what you tell it, which means that you have to be very careful that you have told it everything. You have thought about everything, that there isn't this little tiny rule that you didn't think about to explicitly program. And to just tell you how easy it is, this is my favorite example. When I was asked to give this talk, I was not explicitly told to not give this talk naked, right? This is common sense. You're not going to go on Zoom and give a talk naked. Nobody thinks about telling you to do this, right? But if you are asking a machine to give a talk, then you have to explicitly specify things like not naked. And it is very, very easy to forget a bunch of rules like this. And this is the advantage of the bottom-up approach. It will come up as an example, right? If it is learning from the environment, it will pick up this rule as well, hopefully. Now, as to how do we verify, prove the ethical behavior has been really reached, I think it is interesting here to mention that there is the approach the one approach that has been put forward is to construct an ethical Turing test. So the idea here, very much like the real Turing test, is to put the moral reasoner, the artificial moral reasoner, in one box, and then you have a bunch of ethicists, whatever that means, ask it to solve, to make some choices. And if the ethicist cannot distinguish whether or not what has made their choices is another ethicist or a machine, then what you have is an automated moral reasoner. Now, this is the The top paper is the paper in which the ethical Turing test is being proposed, and the bottom paper is the paper, one of the papers in which people say it is an extremely stupid idea to do this. Okay, so this was the material that I thought was like the very basics of what machine ethics is about, and I just want to give you with some more information because I was not very deep on the details here. So there are two papers which are a systematic review of implemented machine ethics systems. If you want to know more what people are doing, they seem like they are at contemporaries, but in fact the paper on the right, the Suzanne's paper, was older than the paper on the left, UX paper, but they both have a very nice overview of what people have done. And with Luis Dennis, we recently gave a tutorial on ICHK on machine ethics, and particularly if you're interested in the implemented system and the verification and all this detailed stuff, there are nice talks there. The link is to the YouTube channel of which we dumped all the videos because everything is online. Please do ignore the very questionable introduction to moral philosophy that I give there. Nobody should learn moral philosophy from me, but it had to be done, so it was done, but badly. But everything else I can vouch for. And this link, so basically, let me kind of find my this link is the tutorial with all the papers and all that stuff, whereas this is just the YouTube channel in which all the videos were dumped. Just be aware, we actually have the videos in duplicate because originally we thought we have to pre-film the tutorial, but then it turned out we have to do it live, so we ended up with 2 sets of videos. So yeah, enjoy. Okay, so I just wanted to mention some other things. No, bad. Okay, sorry, I clicked on things. These things were not meant to be clicked on. All right, I will rectify the situation. Oh, no. Sorry. I have one more slide left, and then things happened, and this is what happens when you have two. There we go. But now I'm not sharing. All right. Okay, 2 screens, 1 mouse. Okay, we're back on track. Right, so what I have talked about is machine ethics on narrow AI. I think that it should be mentioned that there are people who are thinking about machine ethics on AI that is smart for when we get it. So people are working on how to have machines not follow the rules, because like, for instance, when is a machine allowed to lie to a person, or when is a machine allowed to not follow the instructions from its human operators? And the other thing is, so this one is still very much with, this first one is still very much within like narrow AI perhaps. And then you have people typically that have Stuart Russell in the group, which are, but also some very nice people as well. There, Anka Dragan is a roboticist who is gives excellent talks. I recommend if you have a chance to catch her. How do you design an off switch for a machine? So if you are building a reinforcement learning agent that learns moral behavior, and at one point you want the human to be the final arbiter of its decisions, but this thing has autonomy, how do you design the off switch so that the autonomy of the system does not override the system using its ability to autonomously make decisions, does not override the choice that the person has made? So a lot of interesting stuff there. I don't work in this area, but I think it's important to know that it exists out there as well. Okay. And then what is happening here? Yeah, okay, so that is all that I had from the slides. So one more shameless plug: if you know people who would be interested to move to the far west and do a PhD on topics such as discussed here, we have an open PhD position, deadline 1st of June, AI and logic, but we're very much interested into a PhD student who would be willing to work in machine ethics topics. The student themselves proposes the topic and apply with it. And yeah, so that's the talk. Thanks very much for your attention. Let me relinquish control here. Okay, there we are. And I need to, make sure that I can hear you, because
can you hear us?
Okay, my headset ran out of battery.
Okay. Can you hear us?
Yes, I can hear you now.
Yeah, very good. Very good. Thanks for that. Very interesting talk on a very interesting topic, I think. We have some questions coming in. And so there's two ways of doing this: write in the Q&A or raise your hand if you want to talk. So let's try some of these questions for you, Marija.
Yep.
The first one is, how do you think the new EU Artificial Intelligence Act, and this is only a week old, I think, will influence the field of machine ethics?
Right. So this doesn't touch us so much because what we do very much are prototypes, toy examples, and so on. And the act is, as far as I understand it, again, is about regulating systems that exist. So if we were to build machine ethics capabilities into systems such as driverless cars or other autonomous systems, then of course we have to follow the regulations. And this is the part where I talk about, which is the law part. So that would be the law part that would go into as input. But all the systems that do machine reasoning and moral reasoning at the time are toy examples that have not seen the light of day. So that example that I showed from Twitter, they don't call that moral reasoning. I mean, Twitter does what Twitter does, right? So who knows? We're not involved in that. But it would be, eventually, it would be what is known as the law, and it has to go into somehow into the information, into the left side of the system. Yeah.
There's another one, which I think is interesting. It's from Anders Løland. Sometimes we discuss machine ethics as if the machines perceive its surroundings and the situations it operates in a perfect fashion. Yeah. But as we all know, that's not always happening. So what is the ethical thing to do given these deficiencies?
Okay, so yeah, so if you go into, I didn't want to demoralize you audience too much on this talk, but if you go specifically in the system and I have built one of these systems with the Liverpool crowd, now they're in Manchester. And what we built is a simulation of a driverless aircraft that in some situations can make a distinction between crashing on top of an empty field or crashing on top of a school if it really has to crash, right? So this limitation of the sensory input is part of the reasoning system already. And what you try to do is to give push the decisions into one side or another side, given some moral information, if I'm really hand-wavy explaining what is happening. So that means that we are only able to, such a system would be able to distinguish between crashing on an empty field and crashing on a school, but it will not be able to distinguish between being rude to the captain or not, right? Or long-term consequences of something that is not explicitly programmed into its abilities. So the reasoning is always limited to the abilities of the system to evaluate its environment and discern between the options. That is why this is not a fully moral agent, and this is why the philosophers are angry with us that we're calling these artificial moral agents, because they actually aren't. So this thing is in the same sense that a chatbot that has been trained to answer questions about, I don't know, flight tickets. If you ask it to answer a question about library books, it's going to say something which is going to be complete gibberish. That's exactly the same thing that would happen with these systems, right? It can make some moral decisions in some contexts, but not all of them.
And it could get it wrong, right?
Oh yeah, absolutely, it will get it wrong.
Just like other input. Yes. Sometimes result in the wrong output.
So this thing that the Andersons built, that is solving moral dilemmas in elder care about whether or not you should alert, you're a care robot, and whether or not you should alert the guardian if your charge is refusing to take medication, for example. If you put that same system to, another type of patient, like, I don't know, a hospital patient or a child, it's not going to work. It's going to recommend stuff, but it's going to be nonsense.
Very well. Here's one question from Jon Becker. He says, "Say I have an AI system which has an ethical output. I can make the output ethical by modifying the data or by modifying the algorithm. Which approach is preferable, or does it not matter?
It doesn't matter. So as you will notice, machine ethics systems, they do not use sub-symbolic reasoning, none of them, right? The only exceptions are these reinforcement learning systems. No supervised learning is involved in machine ethics systems. The reason for that is you don't have the data, right? We don't have the data to train systems to do anything here. But I think it raises a very interesting point that I failed to mention. And Winfield and van der List have a paper specifically on that called Dark Side something. That if you can build a system that reasons ethically, you can build a system that reasons unethically. It's a flip of a switch, right? So then in order to, because what you actually is going to get typically is an ordering of available options in terms of how ethical they are. So if you take the bottom, you have a moral system. If you take the top, you have a moral system. If you take the bottom, you have an evil system, right? As to how do you not make evil systems when you can make them if you make good systems? Question for a different panel discussion.
Or maybe you can bring it into this one as well. There's a question here about having challenging discussions with people from social sciences and humanities, and why is that? And it's also a question about whether it says what kind of tension did you see? And in Sweden they have WASP, HS. Do we lack something similar like that in Norway?
Well, we lack the 350 million that the
exactly.
WASP got. I don't know exactly the sum, but it was something. Yes, Virginia Dignum runs that. I'm happy to count her as a friend. So I think that Sweden is doing a great job in actually educating a lot of people in this area, and they don't really work on the machine ethics side so much. They're kind of more on this other AI ethics topics of responsible AI, I think is their main thing. So I think that I have been talking to the other side for a long time, and I have to say basically there is only one source of the difficulty in talking with humanists and social scientists, and that is the misunderstanding of these terms that we all use. So once we are actually clear that what we mean when we say agent and trust and whatever else term willy-nilly that we use is actually different meaning, that if we walk into the conversation with our definitions, there are no problems, and we can have many interesting discussions on this topic. And I think we should have interesting discussions. I spent some time with the autonomous systems people of a workshop that was organized by NTNU together with Lou Gehrig Center in UCLA just this week. The autonomous ships people were there. Here's my examples. And I think that because there is a lot of delusion, right? Because Norway doesn't have a car industry. We kind of consider ourselves exempt from these ethical issues because people just see trolley problems everywhere. And this is a problem for trolley problems. But at the same time, the banks are becoming IT industries. The insurance companies are becoming IT industries. And we have NAV, which is it is going to go at one point automating certain aspects of its service, right? And particularly in this part, I think we need to have interesting and social discussions about what should be done for this particular context of this country. Because all the unethical examples, they come from abroad, and it's very easy to say, oh, well, we don't have this judicial system in Norway that employs automatic decision-making of who is going to go to prison and who is not going to go to prison. Therefore, we don't have a problem. We have other problems. We're just not talking about them. And I mean, I would say that, yeah, we need some serious funding on the thing. I think there are people, and people are ready, and people are doing work already on their own. So, I mean, like me, but also other people. And we're happy to talk to each other. But if we want to shift the narrative from AI ethics being a problem of the Silicon Valley or of the countries who make cars to being actually our problem that's knocking on our door, then yeah.
Very well.
It was a private foundation, by the way, so Norwegian private wealth might want to take this invitation to look at it.
It's not a typical Norwegian tradition. Maybe, unfortunately, I don't know. Anyway, we're reaching the top of the hour. Thanks a lot for a very interesting talk. Thanks to the audience for the engagement. There are still some questions in the chat there. I don't know, Marija, whether you have a chance to if you know these people, or if you have a chance to reply to them. Or if, I don't know, Klaus, if you're still here, if you want to have your regular after party style, that's also fine by me. I unfortunately myself have to leave because I have a meeting that starting.
Yeah, I think also I will have to leave because I have a lot to do before the day ends. But it was a great talk, Marija. Thank you so much.
So I mean, okay, so I'm happy to answer these questions, but